Very good evening to one and all. So it's been 2 or 3 days since we uploaded the last video. Here it is. Relations and functions. We are going to see all the important concepts. Here I am going to teach you right from the beginning. Whatever you guys learned it from the lower classes, we are going to see because it is a very important chapter. And if you learn this chapter with ease, then you will be able to understand the remaining chapters also pretty well subsequently. Uh, so that is why I have given you all the topics right from the basics. That is from your lower classes, whatever you have learned. I have chosen everything and then I have given you. So I hope that this session will be a very interesting session. So let's go into this chapter and let's rock and roll collectively together. Hello guys. So in this session we are going to see relations and functions. So I thought of giving you a complete introduction to relations and functions because this topic you have been learning from your ninth grade onwards approximately. So for the last 3 to 4 years, whatever you have learned will be present here so that you will be able to understand this plus two relations and functions in a very easy manner. So now let us go into the topic. So the following topics are what we are going to cover. So first topic is nothing but ordered pair, very simple topic, Cartesian product, relations, domain and range, functions, types of functions. We have got four basic types of functions, that is one to one, which is otherwise called injective function, many to one function, all to function. All to function is otherwise called surjective function and into function, and the last is nothing but bijective function, which is a combination of both one to one and also on to. And after that we are going to see this page is the basics whatever you have learned it in your ninth, 10th grade and 11th grade and all those things. So with a strong base it would be helpful for you to understand these concepts much better. That is, these are all the topics in your actual plus 2 syllabus. So advanced relations, that is reflexive relation, symmetric relation, transitive and equivalence relation, and advanced functions you have domain and range, and also how will you check whether the function is an on to function or a many to one function, like that there have been some specific conditions which are given. So now let us go into the detailed topics one by one. So now we'll check what is ordered pair. See, it is nothing but the geometrical coordinates which is represented in x and y axis respectively. So 1 comma 3, 5 comma 9, minus 2 comma 1, minus 6 comma 7. These points are used to be plotted in a graph. So these are nothing but the ordered pairs. Next is the Cartesian product. So for Cartesian product you need to know ordered pair. That's why I mentioned what is ordered pair here. So next is Cartesian product. See, I have given two sets, set A that consists of 3 elements 1, 2, 3, and set B that consists of 2 elements A and B. So now A cross B, that cross is nothing but a Cartesian product. So for that cross, what you will have to do is, see, if it is A cross B, you will have to write all the elements of A first, like 1, 2, 3, and then cross A comma B, and then you will have to apply distributive property, which you would have learned it in your lower classes. How will you apply distributive property here? 1, 2, 3 cross A comma B. So it should come like 1A, 1B, 2A, 2B, 3A, 3B. This mapping you should do carefully. I again repeat, 1A, 1B, 2A, 2B, 3A, 3B. But if it is in the reverse, that is B cross A, if they ask you, B cross A will be A cross B. You will have to write the elements of B first, put a cross sign, and then write A as 1, 2, 3. So now B cross A will be A1, A2, A3, B1, B2, B3. Now please note here that the elements of A cross B and B cross A are not equal. 1 comma A is different, A comma 1 is different, because 1 comma A here 1 is there in the x axis, and here in A comma 1 this 1 is there in the y axis. Please don't get confused. So 1 comma A and A comma 1, they are not equal, hence A cross B will not be equal to B cross A. But the total number of elements present in the set, that will be equal. A cross B you have totally 6 elements, and B cross A also you have 6 elements. In fact, it can be found out by a formula. Number of elements in A cross B, that is equal to number of elements of A into number of elements of B. So it is 3 into 2, which is 6. That can be found out very easily. Okay, now I think you guys are able to understand Cartesian product. We will see some more examples related to it. So if A cross B I have given. So if the Cartesian product is already given, then how will you find out A and B? So A cross B is given 3, 2, 3, 4, 5, 2 and 5, 4. With this you have to find out A and B. So A from this is very simple. That is the first, see here it is given as a first element. So the first element should always be taken as A. So here 3 is used twice, you just use it once, and 3 and also 5 is used twice, you use it once. So A is nothing but 3 comma 5. Similarly B, which is the second element of the set, so it should not be repeated more than once. If it is repeated more than once, use one value only. So B is nothing but 2 and 4. So A is nothing but 3 and 5 and B is nothing but 2 and 4. So this is, if the Cartesian product is given, this is how you will have to find out the value of A cross B. I mean A and B. Now we'll go to the concept of relations. I think with this, the concept of ordered pairs and also Cartesian product gets clear for you guys. Now with this we'll go to the concept of relations. So there is a question. Before that we'll directly see the question to understand the concept of relations better. So the question is, if A is equal to 1, 2, 3, 4 in set, B is equal to A comma B comma C, which of the following are relations from A to B? I have written the questions here. There are totally 3 questions. So for this, the first step I'll tell you, for relation to exist from A to B, first you find out the Cartesian product of A cross B. So what will be the Cartesian product of A cross B? A cross B. So 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C, 4A, 4B, 4C. I again repeat, 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C, 4A, 4B, 4C. Everything is in bracket, ordered pattern. Right? So that's why I told you in a simple language. 1A means 1 comma A in ordered pairs. So like that you'll have to do. And after finding out the Cartesian product, always remember these questions should be a subset of the Cartesian product. So check whether 1B is there in Cartesian product. Here itself you can check 1B is there, 1C is there, 3A is there, and 4B is there. So this first subdivision, it is a proper relation from A to B. But if you see the second question, 1A is there, B4 is not there. So this second question, the second subdivision is not a relation from A to B. Similarly, the third question, 1A is there, A1 is not there. A1 is not there. So this is also not a relation from A to B. Now I think you guys are able to understand it better. So for a relation to exist from A to B, simple thing is find out A cross B and check with your given question. Your given question should always be a subset of your Cartesian product. Subset means whatever the elements given in your question should be present in the Cartesian product. If it is present, then it is a relation. If it is not present, it is not a relation. As simple as that. Okay. Now let us go to the next topic. That is domain and range. So here A is 1, 2, 3, 4, 5 and B is Madhi, Arul and John. So here domain, I will explain you in a very clear way. Domain is nothing but the used part of left hand side. Please understand this domain is in a relation, not in a function. In function it has a different meaning. Of course meanings are similar, but there will be a slight change with when you compare relation and a function. So in a relation, domain has got different significance. So that is used part of your left hand side. What is the used part of your left hand side? Only 4 values are being taken. So this is nothing but your domain. And range. Range is nothing but your used part of your right hand side. What is the used part of your right hand side? Madhi, Arul and John. So this is nothing but your range. And codomain is your entire right hand side. Codomain is your entire right hand side. So here range is equal to codomain. That is a different story. But domain is nothing but, I again repeat, in a relation, domain is nothing but the used part of your left hand side. Here it is 1, 2, 3, 4. Range is nothing but your used part of your right hand side. And codomain is your entire right hand side. So now let us see one more example. So I have given another example. So from this P and Q, 5 is mapped to 3, 6 is mapped to 4, 7 is mapped to 5. So here you can see that P I mean, the domain is nothing but the use part of your left hand side, which is 5, 6, and 7, and range and codomain. Both of them are same because everything is used on the right hand side. So range is also 3, 4, and 5. Codomain is also 3, 4, and 5. So with this, the basic concept of relations are over. I hope that you guys are able to understand. We will see some other relations, that is the one given in your 12th standard syllabus, a little later. After we cover the basics of functions, we can go to that. Okay, now we will see what is functions. Functions, see in this diagram, it is very clear to understand from this diagram. A function is always a subset of relation, and a relation is always a subset of Cartesian product. I told you this. Relation should always be a subset of Cartesian product. Similarly, a function is always a subset of relation. So if you understand the concept of relations better, understanding functions will be a lot easier. Okay, now we are going to check whether the given mappings or functions or not. So it is a very simple. I have given you many examples here to understand the concept of functions much better. As I told you, relations checking is different, functions checking is different. They have got some slight difference. We will see what it is. So A and B. Here you can see that A is mapped to P and B is mapped to Q, C is mapped to R. Here what I do is I simply take A, B, C as student. Yes, I take A, B, C as students, set students, and I take P, Q, R as teachers. So with the student teacher example, this concept of functions can easily be demonstrated. See how? Let us look at how. A, B, and C, they are mapped to P, Q, and R. That means different students, they have different teachers. So it is a proper function. Now let us look at B. Now student 1 is mapped to teacher M, but whereas student 2 and student 3, both of them are mapped to N. So here what can you see? Like both the students have got a common teacher. That is possible. Both the students in your school itself, multiple students are studying and a common teacher is taking the class. So that is possible. So it is also a function. That is why B is a function. A is an example actually, B is also an example, C is another example. But if you see in C here, A is mapped to X, that is student is mapped to a teacher, but you have got a single student mapped to two different teachers. See, this is possible only when it is both of them are studying different subjects. Mathematics a teacher will be taking, physics a teacher will be taking. So here what we are supposed to see is, what we are supposed to analyze is, it is a single subject. For a single subject, two different teachers are not possible, at least in a school. At least in a school, two different teachers are not possible. So case C is not a function because of that. Please understand the difference between B and C. Here in example B, two students are having a common teacher. That is possible. But two students cannot have a single student cannot have two different teachers. That is not possible. So that is the difference between B and C, and that is why B is a function and C is not a function. We will see some more examples. So here I have given not a function. See, this is why I told you in relations and functions there is a slight difference. Here it is not a function at all, because 4 being a student is left alone. If a student is left alone, then it is not a function at all. It is partiality. In fact, all the students except 4 are having teachers, but student 4 is left alone. He or she is ignored. Ignorance case, so it is not a function. So like this only you guys have to understand these concepts. So if you understand this in this manner, then these concepts become very easier to understand. Okay, now let us see the next example. So here in example D, simple case, 4 is left alone, so it is not a function. First you will have to, if they are asking you to find whether it is a function or not, you just have to see whether all the elements on the left hand side are mapped first. If any of them is left unmapped, then it is not a function at all. Straightforward case you can write straight away. Okay, now let us take example E. Example E, it's just like example B. minus 5 is mapped to B, and 1 is also mapped to B. That means what? Two students, minus 5 and 1, have got a common teacher. That is possible. And 3 is mapped to A and 4 is mapped to C. So it is a proper function. And F here, if you see, minus 5 is mapped to A, but 1 is mapped to both A and B. That means a student is studying with two different teachers for the same subject. I told you already, it is not possible, at least in the school level. At least in the school or the college level, a teacher has to study one subject with one teacher only. So here the student is studying with multiple teachers and the two the same subject, so it is not a function. So that is why F is not a function. So I think that these examples illustrate the concept of functions much better. Now we will see additionally some more examples for types of functions. So types of functions I have given. So there are many types of functions: one to one, many to one, all to one, into, as we have already seen. So now let us look at the examples. If different elements of left hand side are mapped to different elements of the right hand side, so that means it is a one to one function. So here you see C and F, set C and set F. So here 1 is mapped to C, 2 is mapped to A, 3 is mapped to D. So first of all, it is a function, and also it is many to one, one to one function, because different elements of left hand side are mapped to different elements of the right hand side. And many to one function, I have given an example. We have already seen, that is two students are having the common teacher. So that is many to one function. Typically two students, 1 and 2, they have the common teacher B. 3 is mapped to C, 4 is mapped to E. So this is typical case for many to one function. And onto function, it's very simple concept. Range should be equal to codomain. If range is equal to codomain, range means what did I tell you in the relation? The same concept applies here also. That is the used part of the right hand side. Codomain is your entire right hand side. So here the used part of the right hand side, here all the values are being used. So L, M and N, this is nothing but your range. Codomain is also L, M and N. So if used part of your left hand, right hand side and codomain are equal, so hence it is called an onto function. Simple as that. Into function, here itself you can see 1 is mapped to W. It is exactly the opposite of onto. That means range should not be equal to codomain. So here if you see, the range is W, X and Z, but whereas codomain is W, X, Y and Z. So here range is not equal to codomain, and hence it is an example for into function. So I think you guys are able to understand the concept of domain, range, codomain for functions, relations, how to find out whether it is a function, how to find out the different types of functions, and all those things. Now with this, we go to the concept of 12th, that is the 12th syllabus. So advanced relations, reflexive relation. If A comma A belongs to R, for each small a belongs to capital A, where capital A is a set, symmetric. If A comma B belongs to R, which implies B comma A should also be a part of R. So I have given examples for reflexive, symmetric and transitive, so you need not worry about it. So transitive, even if you are not able to understand from this definitions, you will be able to understand from the examples much better. So you need not really worry. Transitive, if A comma B belongs to R, and if also B comma C belongs to R, then A comma C should belong to R. So for C, this symbol means for all values of. So for all values of A, B, C belongs to a particular set. Equivalence is a combination of all these things: reflexive, symmetric and transitive. So now let us see some examples. I have given an example. Let us set A is 1, 2, 3. Here a relation is defined. Please see carefully. 1, 1, 2, 2, 3, 3. Everything is present. So it is a reflexive relation. Apart from this, anything else can come. Any other thing else can come, but mainly 1, 1, 2, 2 and 3, 3 should be present. If it is present, then it is a reflexive relation. And similarly, second case, a set is given 1, 2, the opposite of it, 2, 1, 1, 3, opposite of it, 3, 1. If that is present, then it is called as symmetric. And similarly, transitive 1 comma 2 comma 3, 1 comma 3 should be present, 3 comma 2, if 1 comma 3 and 3 comma 2 are there, then 1 comma 2 should come. So here it comes, so hence it is called transitive. So with this, I think you are all able to understand the concept of relations of the higher class much better. Okay, now I have given you some key points. These key points are mainly available for mainly applicable for 1 mark questions, MCQs. So total number of relations from a set consisting of m elements to a set consisting of n elements. See, suppose if A contains 3 elements and B contains 4 elements, so the total number of relations from A to B, it is nothing but 2 power mn. So it is nothing but 2 power 3 into 4. The example what I told you, A contains 3 elements, B contains 4 elements. So the maximum number of possible relations is given by 2 power mn, where m and n are nothing but the number of elements present in the first set and the second set respectively. So by knowing this formula, you can see how many relations actually exist and number of reflexive relations on a set. So these are the key formulas which you got to know, which is nothing but 2 power n into n minus 1, where n is represents the number of elements of the set. So number of reflexive relations, that is the same number 1 1 2 2 3 3 like that. So 2 power n into n minus 1. And number of symmetric relations, opposite pair 1 comma 2 means 2 comma 1 should also be present. So number of symmetric relations on a set with n number of elements is given by this formula, 2 power n into n plus 1 by 2. And a combination of reflexive and symmetric relations, it is nothing but 2 power n into n minus 1 by 2, where n commonly represents the number of elements present in a set. And advanced functions, I have given you 1 to 1, check for 1 to 1, and we have already checked from the function mapping diagram how will be 1 to 1 function and how will be onto function like that. But here it is an advanced check which you guys have to use it for your 12th grade to solve the questions. For every x1 comma x2 belongs to x, f of x1 equal to f of x2. If it is equal, then x1 should be equal to x2. If this is satisfied, then it is a 1 to 1 function. I have given an example also, f of x equal to 2x. So let this be a function. F of x1, we are assuming that f of x1 equal to f of x2. So that means 2x1 equal to 2x2. So from here 2 and 2 will get cancelled. So which implies x1 equal to x2. And so this condition is already satisfied and hence it is a 1 to 1 function. So this is how 1 to 1 function has to be solved. And if it is, suppose if this condition is not satisfied, if x1 is not equal to x2 for some questions, then the given function is automatically many to 1 function. So okay, now let us go to the next topic, that is check for onto function, f of x equal to 2x. So step 1, we are assuming f of x equal to y. So what will this expression be looking like now? So y is equal to 2x. Now we need to find x and then substitute it in your question again. So y is equal to 2x, so which implies x is equal to y by 2. So yeah, instead of x we are substituting y by 2. So if we substitute 2 into y by 2, 2 and 2 will get cancelled and you will be getting y. So and if f of x equal to y, the assumption what we made, if it comes true in the end, then it is an onto function. If it is not true, then it is into function. Straightforward swap between onto and into. So this is the easy concept of understanding functions now. So some key points for functions I have given. Let A and B be two non-empty sets. Non-empty sets means there must be at least one element in each set. So such that n of A equal to P and n of B equal to Q. Number of functions from A to B is Q power P. Again, these are the these are the models which can come in MCQs. So you guys have to remember it. Number of functions from A to B is Q power P. Suppose if it has 3 elements and if it has 2 elements, so if they are asking you how many functions are possible from A to B, you just simply have to write 3 square, which is 9. So number of 1 to 1 functions from A to B. So here you have a specific condition. It is nothing but QPP. Please note that this capital P stands for permutation. NPR, NCR, permutations, combinations, you would have done in 11th, right? So that thing you will have to use. QPP. So QPP, where this small q and small p are nothing but the total number of elements present in B and A respectively. So Q, P, P, if P is less than or equal to Q. If P is less than or equal to Q, you got to apply this condition. If P is more than Q, then the total number of one-to-one functions becomes 0. So please understand this, when to use which formula and all, please try to learn. Next, number of on-to functions from A to B. Here itself, here also you have got two cases. So first is summation R is equal to 1 to Q minus 1 per Q minus R, Q C R, R per P. So if P is greater than or equal to Q, you got to use this condition. If P is less than Q, then it will be 0. This is for onto function. Number of onto functions defined from A to B. See, rarely these type of questions is asked. Suppose if they are asking you, you guys have to use this formula. That's all. So next is number of bijections from A to B. Bijections already we saw 1 to 1 and onto. So it is nothing but P factorial if P is equal to Q. 0 if P is not equal to Q. So with this, the entire concept of relations and functions is over. I hope that all of you are able to understand this concept of relations and functions. I have given you numericals also, examples and exercise from both the first exercise and the second exercise. All these things are taken from the new edition of the textbook. So I hope that for all of you this chapter is very clear, and if you have got any doubts, I have given my WhatsApp number. You can feel free to book for a class and contact me. So all the very best guys, and have a nice day.
Fall apart.